Hello and welcome. In this video, we will take a look at how you can efficiently perform a regression test with a diagnostic simulation. My name is Thomas Blocher. I work as an application engineer and trainer at Softing Automotive. After changes to a diagnostic service tester, it must be subjected to an overall test to ensure that no existing parts were disturbed during the change. The better the test coverage in this process, the more certain it is problems and rework will be prevented in the field. However, many model years, model series, equipment variants, and software versions may be affected. For this, the corresponding test items must be available in the regression test. For complete regression test, all vehicles must be available in all variants. Logistically and in terms of budget, not all vehicles can be kept in stock in all variants. Test gaps will arise, which leads to expensive adaptation cycles after the release. How can we overcome this problem? The problem can be solved by different approaches. One solution would be to have a programmed environment which simulates the ECU's diagnostic behavior. But this is too complex and time-consuming in most cases. A diagnostic simulation with real communication is a better solution. For the regression test, it increases the quality by allowing greater test coverage. It saves money by eliminating the need for troubleshooting loops and multiple rollouts. Saves time as the rollout can take place earlier. Saves time because the degree of test automation can increase, and saves money because no test vehicles have to be kept in stock. A diagnostic trace is a record of the real communication between the diagnostic tester and the vehicle of the control modules. The record needs to be analyzed and converted into a simulation. Diagnostic services with their diagnostic responses are automatically assigned to the corresponding ECUs. This is done fully automatically. Any vehicles can be archived in this way for later use. The solution is a simulation that recreates the control unit or the vehicle in relation to the diagnostic behavior. An example of such a diagnostic simulation is Softing TCS. The solution consists of 3 building blocks. The first one is Softing TCS admin, the configuration interface for simulation files. Softing TCS device represents the hardware for the simulation of vehicles or ECUs. And Softing TCS Test Bench enables integration into test automations. In the following demo, I am going to show you how to create a diagnostic simulation for a new vehicle variant with Softing's TCS administration tool. This simulation allows us to perform a regression test for a service tester with the new diagnostic functionality of the model variant. TCS admin is utilized for configuring simulation files, including electronic control units, communication parameters, and diagnostic services. The start page provides a section for tasks such as creating a new simulation from scratch or updating a simulation from a trace file. Additionally, individual tools can be added under the Tools section, such as a Notepad application. The Recently Used Items section displays a list of simulation files that have recently been opened. This demonstrates the diagnostic CAN communication trace that we have recorded with a new vehicle model. It includes the ECU's diagnostic CAN identifiers along with the corresponding requests and responses in hex format. All requests and responses are tagged with the relative timestamps, allowing TCS to create a time-accurate simulation. Next, we aim to update a diagnostic simulation file for the existing ECU variant with the trace record of the new model variant. The existing simulation file contains the definition of the ECU's base variant and their variants, with 3 different modules available: the airbag control module, an engine control module, and a roof control module. All diagnostic services occurring in the simulation are listed here in a structured manner, taken from the UDS ISO 14229 diagnostic protocol standard. Prior to parsing a CAN trace using TCS, it is necessary to define the communication parameters. Specifically, the CAN identifiers associated with the base variants in the current simulation must be defined. This allows for the processing of messages linked to the CAN identifiers found in the trace file. Next, we proceed to import the CAN trace file. We navigate to the ribbon bar and select Import CAN trace, then choose the previously recorded vehicle trace. The trace is added as a separate variant with the corresponding diagnostic requests and responses. Once downloaded to TCS device, the new vehicle variant simulation is available for regression testing with a service tester. Let's summarize what we have seen so far. The lack of ECUs of vehicles during regression testing can be overcome by a diagnostic simulation. It is time-saving by making all devices under test available via simulations. It provides significant cost advantage through higher automation and the avoidance of rework, enables noticeable quality improvement since basically all test cases can be represented. A case-oriented simulation can be easily generated by a trace import. My name is Thomas Bloche. Please feel free to contact me if you have any questions. Visit also our virtual showroom, where you can experience our products from a fresh perspective, wander through our digital environment, interact with our solutions and gain insights into typical use cases, and see firsthand how our offerings can benefit your business. I am looking forward to seeing you in our next video.